Good afternoon, good afternoon all. I'm Rabia Hanfi, Assistant Professor at IIT Bhopal. Today we are going to learn about MapReduce. As far as the MapReduce concern, it comes under cloud computing, which is 8th SEM subject, and it comes in 8th semester cloud computing. It's a subpart of MapReduce is a subpart of cloud computing. It is very important part. So now we are going to see what is cloud MapReduce. So first of all, in MapReduce, we are going to learn about introduction, algorithm, input and output, and terminology. So first we are going to cover about introduction of MapReduce. Uh, MapReduce. In introduction part, we are we are basically learn about what is MapReduce framework and how it is used, and basically what is MapReduce. So MapReduce is a framework in which we can write different kind of application and process huge amount of data, and that particular data is processed parallelly and on large clusters and different reliable hardware. So basically MapReduce is a framework in which we can write different kind of applications for large amount of data and different kind of hardware support. Next, what is MapReduce? So MapReduce is a processing technique and a program model. It is used for distributed computing and it is based on Java. MapReduce algorithm contain two parts, map and reduce. Map takes the set of data and convert it in another type of data where every element is broken down into tuples, and that tuples consist key and values pair. Secondly, we're going to reduce that particular task, which takes the output form of map. Means map, in the map activity we get the what kind of output we get, that particular output is used in reduce task. That particular output act as an input, and then it's combined in different tuples and a smaller set of tuples. So as a sequence name, map and reduce. That's why we are calling it map reduce framework. Now, major advantage of map reduce is it is easily scalable, easily scale the data over multiple computing nodes. Under map reduce model, different primitive data is processed, and uh, different data is processed, which is called by mapper and reducer. So basically MapReduce model data processing or processing of data is called mapping, or we can say mapper and reducer. Decomposing a data processing, MapReduce is a decomposing data processing application. So here basically we are going to decompose the data into mapper and reducer. Sometimes these mapper and reducer are non-trivial, but once we write an application in a map reduce form, then scaling of the application uh, to run over hundreds thousand, even 10,000s of machine in a cluster is merely configurations change. Means once you are going to write the application in a map reduce, then you can scale the data, you can run that particular application over hundred thousands, even 10,000 of machine. The cluster configuration is merely change, it's not going to be changed. This simply scalability, this simplified scalability of this map reduce program attract different programmers to use that particular model. Next, we are going to learn about algorithm. Generally, MapReduce paradigm is based on sending the computer to where the data is resides. Means here where the we are going to send the computer where the data is reside. So basically, MapReduce consists of three states. That stages are namely map, shuffled, and reduced stages. In the stage of map, the mapper or map job is to process the input, and generally this input data is in the form of file or directory, which is stored in the Hadoop file system. Hadoop file system is also called HDFS. This input file is further processed by the mapper function line by line. The mapper processes the data and creates several small chunks of data or information. Then reduce state comes. In reduce state, this is the combination of the shuffle and reduce. Then here reducer's job is to process the data comes from the mapper. After processing that particular data, new data set is generated as an output, which will be going to store in a HDFS. Next, during this map reduce job, Hadoop Hadoop sends the map and reduce task to the appropriate server in the different kind of clusters. This framework manage all detail of the data passing such as data passing details such as issues task, verifying task, completion task, and copying data around different servers or around or between different servers and nodes. Most of the computing going to take place in different kind of node where different data is located. So here network traffic is also decreased. After completion of that particular given task, cluster collects all the reduced data to form an appropriate result, and then send this particular result to the Hadoop server. This is basically the process of map reduce. Now this figure is shown about the total algorithm. Here we are going to map the data. Mapper is going to perform the task. Further, that map function or mapper gives the output as an input to reduce function. Here go data is going to shuffle, arrange, manage, and reduce. Then it gives the data to the Hadoop server. Next, inputs and output. So here basically MapReduce framework operates on key and value pair. That framework views the input as a key and pair, and then produce a set of keys and value pairs as an output. So it is kind quite convincible to different types of data and different types of application. The key and the value classes should be in serialized manner. The framework need to be implement the writable interface. So key classes have to implement the writable and comparable interface to facilitate sorting by the framework. So here basically MapReduce job is taking input as a key one and value one, then we are going to map that particular data in key 2 and value 2, then it's going to reduce and save in key 3 and value 3 in the Hadoop server. So this is particularly a framework which we are going to use. Now next we are going to see the terminology. Here first come payload. Payload application implement the map and reduce function and form the core of the job. Next mapper. Mapper maps the input key value pair to a set of intermediate key value pair. Name node. Name node that manage the Hadoop distributed file system. Data node where data is present in advance before any processing take place. Next, master node. It is a node where job tracker runs and accept job requested from the client. Slab node. Here map and reduce program run. Job tracker, here scheduler jobs and tracks the assigned job to the task tracker. Next, task tracker. Task tracker tracks the task and report the status to the job tracker. Job is basically a program which is under execution of mapper and reduce Next is task attempt, a particular instance of an attempt to execute a task. This is a particular instance. Task attempt is a particular instance of an attempt to execute a task on a slave node. Now we are going to learn about how to interact with MapReduce. So here we are going to see different commands like submit, status, counters, kill command to kill the job, counters, which is going to print the counter value, status. Here we are going to print the map and reduce compilation percentage, submit the job for submission any job. Next is history. We are going to check the history list. In this particular command we are going to see all the jobs done by the map function. Kill the task, here we are going to kill the task, means all all the tasks which are not counted or failed, we can kill them. Failed task, yeah, here this is shown the failed task status. Set priority, in which we are going to prioritize the job. Next is continue in next lecture. For now, I am going to end this lecture. In next lecture, we are going to learn more about cloud computing. Thank you. Stay tuned and keep learning with our SIRT.